In this season of your life, what mission are you on?
My main mission now is to warn people how dangerous AI could be.
For decades, AI used to be simple.
We have a flat tire.
How do I tie a bow tie again?
Show me photos of me and Loretta.
The shortest route is available.
Then everything changed in 2022.
This is like a crazy amount of power for one piece of technology.
DeepSeek.
Claude for the AI of today has already changed what it means to be a student by a pretty considerable degree.
Grok 4 is smarter than almost all graduate students in all disciplines simultaneously.
At the beginning, what you saw is traditional AI. These AIs recognize patterns and decides an answer. Now, let me give you a scenario. Imagine a librarian who's good at finding the perfect book from the library for you to read, and now with advanced training, that same librarian has transformed into an author who can write new books based on your request. The librarian here is the traditional AI and the author is what we are seeing today: ChatGPT, DeepSeek, Claude, and so on. These are called large language models or LLMs, and they fall under the concept of generative AI. This is in traditional AI. Unlike older systems that just recognize patterns and pulls answers from data, these models can generate entirely new content. They don't simply fetch information from the web or the training data. They respond with a level of understanding and the ability to generalize almost like human intelligence. But have you ever wondered how this thing actually works? Because we didn't just stumble onto it. We built it through years of trial, error, and failure. And if you stick around till the end, you will realize how the hell we came this far. So without further delay, let's dive in. To understand LLM, we need to understand what AI is. Because AI is not something that emerged all of a sudden. It came before we were born, during the 1950s. So what is AI? Artificial intelligence is the technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy. The evolution of it starts here.
In the 1950s and 60s, scientists built a few working perceptrons, as these artificial brains were called.
He's using it to explore the mysterious problem of how the brain learns.
This perceptron is being trained to recognize the difference between males and females. It is something that all of us can do easily, but few of us can explain how. To get a computer to do this would involve working out many complex rules about faces and writing a computer program.
Back in the 1950s, a software called perceptron was invented, a single-layer neural network. We called it a neural network because our own intelligence comes from the brain, which is made up of billions of neurons. So, in an artificial sense, we gave it the same name. This network worked based on three things: inputs, weights, and a step function. Inputs are the data we feed into it. Weights decide how important each input is. All the weighted inputs are added together. A bias is applied to shift the decision boundary, and then the step function gets in. The step function checks the sum. If it's above a certain threshold, the perceptron outputs 1. If it's below, it outputs 0. The perceptron could handle simple 2D problems like deciding what's tall or short, or recognizing hot and cold temperatures. But it couldn't spot the difference between a cat and a dog, because that requires recognizing edges, analyzing 3D features, and much more. And that's when we leveled up. We developed multi-layer neural networks, a stack of perceptrons working together. This solved the infamous XOR problem and allowed machines to identify edges, shapes, and objects. Finally, AI could tell the difference between a cat and a dog. But there was a catch. These networks still couldn't solve complex problems all at once. They lacked real understanding and logical reasoning. A perfect example is, it might suggest you to pour water in your laptop to cool it. Not smart, right? We also faced challenges like limited data, slow computers, and high electricity demands. Then everything changed. The 2010s brought the deep learning era. The internet exploded with billions of images, videos, and text. GPUs solved what we failed at before. While CPUs tackled one problem at a time, GPUs could attack 1,000 problems at once. Deep learning achieved 50 to 1,000 layers instead of 3 and 4, with millions to billions of weights. Each layer built on the previous one until finally we could get the output we wanted. So thanks to GPUs, big data, smarter algorithms, and cloud computing. Then things got practical. Apple Siri understanding voice commands, AI helping doctor spot cancer in X-rays, and so on.
Who's taller, Kobe or LeBron?
If you squint, you can see that LeBron James is slightly taller.
But what we are seeing today, it's not just another step forward, it's a fundamental shift. And what's coming next is just a more powerful version of what we are only beginning to see now. So let's understand how LLM actually works. An LLM is a generative AI. Gen AI is something that generates text, images, code, video, audio, etc. LLMs primarily generate text, code, decent images, and some others. But let's focus on the text generation because we are using at the most to get text-based answers. Ask something in a chat box and it generates a beautiful text for you. It can be a tutor, a content writer, a creative assistant, and so many others that you can name. But at the LLM's heart, it plays a sophisticated game of fill in the blank, which is something that predicts what should come next when you give a prompt. ChatGPT, DeepSeek, Grok, Claude, etc. are popular LLMs. These LLMs works based on certain categories: neural networks, deep learning, transformers, massive training data, and probabilistic generation. Neural networks and deep learning are similar to what we saw before. So let's hop on to the transformer architecture. This one paved the way for LLMs. Okay, we saw how neural networks got upgraded. RNN helped process text word by word and were designed to read from left to right. This was cool at that time, but it had flaws for an AI concept. Some flaws were, they forgot how important each context is, they couldn't understand relationships between distant words, processing was slow because each word had to wait for the previous one, and they struggled with long-range dependencies. The solution? Transformer architecture. In 2017, researchers from Google published a paper with this title, Attention is All You Need. Think of giving the model the ability to look at all words in a sentence simultaneously and decide which one are the most important for understanding. That's exactly how transformers help. It used self-attention mechanism combined with parallel processing. Now, when you enter the prompt, it converts into a token, smaller units that computers can handle. The logic is, words become math and math becomes final text. Let me simplify it. If you write hello world, each word is converted into tokens. But today's tokenizers are smart, as they can handle many common words as a single token to reduce complexity. Next, the token gets converted into a high-dimensional vector, where these are embedded to capture a semantic meaning. Words with similar meaning end up with similar vector representations. For example, king and queen might have vectors that are closed in this mathematical space. Then comes the neural network, but with the transformer architecture. The transformer processes these embeddings through neural network layers where early layers focus on basic grammar and word relationships. Middle layer understand the concept and meaning. Later layers handle complex reasoning and context. Each layer has millions or billions of weights or parameters that determine how much information flows through the network. A 7B parameter model has 7 billion of these weights, while a 70B model has 70 billion. ChatGPT had 175B parameters for GPT-3 at that time. Now, there are rumors spreading that it has 1.8 trillion parameters for the latest model. Next, LLMs plays a game of what comes next. If the sentence is the capital of France, the model does a probabilistic approach. A correct answer must be fitted, and that's where the sampling techniques takes place. The sampling techniques used are greedy, top K, top P temperature. The sampling is implemented by writing code which is done by AI researchers and engineers. But instead of the core concept, let's involve ourselves with a good example. For example, if I ask ChatGPT to write the dog ran towards thee, it thinks the answer might relate to a story. Sampling works based on these formulas, but as I said, let's make it clear to understand. Let's take the dog ran towards thee and build few sentences with each method to understand sampling. Greedy sampling picks the safest option every time. For example, the dog ran to the park and it stayed in the park. It's safe and it's predictable. Now, temperature sampling works based on its value. Lower the value, smaller the changes, and higher the value, higher the changes. Things get creative when the temperature value is high, which kind of provides an odd result. Top K sampling picks the likely words based on the K value, which helps to prevent words with low probability to get in. Top P sampling picks the smallest set of words where the combined probabilities add up to 90%. A natural balanced text is what we get. It's like a spinning wheel, but it's smarter than that. The wheel isn't equal. Words like park get bigger sections because they fit better, based on everything the model has learned. Sampling just decides how much it sticks to the bigger sections or explores the smaller ones. Sampling is the reason we get different answers from the same prompts. These 5 processes get repeated again and again until a good response is met. And finally, detokenization happens, where the tokens are converted into human-readable text. LLMs are trained in 3 phases. The first one is pre-training. In this training, the model reads massive datasets, learning to predict the next word in a sentence. It adjusts its weights using backpropagation, where errors are calculated and propagated backward to improve predictions. Supervised fine-tuning. Humans provide Q&A example pairs to teach the model to respond helpfully and relevantly. RLHF. Human raters rank model responses, and the model learns to prioritize helpful, honest, and safe answers aligning with human values. Okay, we have seen how LLM works and how they learn. But is that it? Is this really all you need to know? And the answer is absolutely not. There are more concepts into it. What I have shown you is just the surface. But here's the truth. This isn't as impossible as it looks. LLMs are insanely powerful, but with that power comes challenges that we cannot afford to ignore. Challenges that today's LLMs facing are hallucinations. These occur due to specific technical factors including training data biases, model complexity, pattern misinterpretation, insufficient grounding in factual knowledge. There is lack of creativity and critical thinking. Also, we got some environmental issues. Training these models consumes massive energy that could power a small city. And then there's us. Just like GPS made us forget how to navigate, LLMs might quietly erode our problem-solving skills. Especially with the rise of AGI and superintelligence, it could become much worse. But no worries until you're prepared, right? AI is essential for the future. People might worry about the rise of AI, but you need to know it's hard to push our life forward without it. One who learns to understand it enhances their problem-solving skills, and they eventually lead the way. If this perspective resonates with you, hit like and subscribe. I would love to hear your thoughts in the comment section about our discussion. Your ideas fuel my next videos. Thanks for watching.